what is the binomial distribution? Guys, you're welcome to my YouTube channel again. Today we are doing like and subscribe. Please, I beg you, like and subscribe. Why? A lot of you watch the videos.
Okay.
You like and subscribe. I have to even write it in my YouTube this thing. The friends and thumbnail.
Yeah, true.
Okay, so since the previous video we didn't capture some of the things well, so in the next example, so I'll take time and explain it. So my machine is running slow. Connect to this thing.
See on YouTube, you are cool.
Yeah, Charlie, it'll be intro to the song, to the lesson. Now let's take another question. And I'll be explaining why the question is a binomial probability distribution. See, let's see if I can get some of the Nigerian questions. Now, another simple question. This is example 2. Let's bring this question there. So it says in a family of 6 children, put it as 100. A family of 6 children, if a child is likely to be a boy as a girl, find the probability of selecting exactly 3 boys, at least 2 girls, and at most 2 boys. Now, this English over here is very important. If a child is likely to be a boy as a girl, it means the chances of being a boy is the same as chance of being a girl. You get it?
Yes.
We have a boy, girl, right? Raised to the power 6. Now, what makes this question a binomial probability distribution? One, binomial probability distributions are having mutually exclusive events, right? Meaning only 2 possibilities can happen, right? It's either you are a boy or a girl, success or failure, win or lose, score a penalty or miss a penalty. Only 2 outcomes: hit a target or miss a target. You understand? Now, the second thing is that
Okay.
there's a specific number of trials, or let me say fixed number of trials. So over here, what are the fixed number of trials? It says in a family of 6 children, right? So the children altogether are 6. These are the number of trials, right? Now they say you find the probability that exactly 3 boys and not the rest, right? And also, most of the time, the question is highlighting on one. Highlight on one. So our focus should be on the highlight part. Now, for the I part, say that probability of what? Now, this is the formula where the capital is the event, the small x, the event of success. This is the event, right? And this whether it will be successful or not, right? And this is equal to A combination x, P exponent x, Q exponent n minus x, right? The P is success, this is a failure, or it can be the boy or the girl, win or lose, right? dead or alive. But in all these cases, your question, you have to focus on the question. Oh yeah, the question is focusing on boys. So the boys will be what will be focusing on. So P exponent boys. We want boys to be exactly 3. Are you okay?
Okay.
So this means that if you want boys to be exactly exponent 3, then girls will be exponent what? 3. So that 3 plus 3, you get 6 combination. Now, are we picking this foot or we are picking this foot? Over here, the question is focusing on boys. So you're going to pick the exponent of boys. You get the
3.
idea? So
Yes.
this becomes the foot of the combination. So it becomes 6 combination 3. What's the probability of boys? Now let's do the probability of boys. So the question is going to be what? Half. Because they say that if a child is likely to be a boy as a girl, it means that your chance of being a boy is the same as your chance of being a girl. But let's go look at the explanation that they have over here. Yes, it's half. Assuming selecting a boy is a success, the probability of success is half. Right? So that's the English explanation over there. So over here, probability of boy is half, probability of girl is also half. So this becomes half exponent 3, which eventually becomes the foot of the combination here. Then half exponent 3. This 3 here should be 3, so that 3 plus 3 will give you 6. Now the rest is calculator. The calculator. So open bracket 6 combination 3. Give me the answers if you've punched it. That's over 16. Yes, and I had 5 over 16. Are you okay?
Okay, sir.
Okay, now the second one says that what? Probability of what? At least 2 girls. Now, at least means the number and above, right? Whenever they say at least, hello,
Yes, sir.
whenever they talk about at least, think about the voting age. What's the voting age? At least 18. Meaning anybody who is
18.
18 or above can vote. So this means that at least 2 girls. It means the girls should be greater than or equal to 2. Are you okay?
Okay.
And in this case, when we are listing
Yes,
the
sir.
elements, right, we can have a situation where there's 0 girls, or 1 girl, or 2 girls, or 3 girls, or 4 girls, or 5 girls, or 6 girls. These are the number of what? Experiments. But if they want 2 and above, at least 2, it means we want the exponent of the girls to be 2 and above. Are you with me?
Yes, sir.
Very good. Now, this approach is the same as using the opposite, which is 1 minus the probability of what? What's the opposite of anything greater than 2? It is anything less than 2. Are you okay? If
Yes.
something is not greater than 2, it means automatically it's less than 2. Now, let's list the things which are less than 2. It is 0 and 1. I get the idea. So this one becomes 1 minus
Okay.
the event of 0, the event of what? 1. The event we're talking about Jane having exponent 0. Right, so this is the answer. So you can choose to do it this way, whereby you have Jane. Now, the first one is what? Boys and girls. So if boys, we have girls. One is a situation where girls is having exponent 2. If girls has exponent 2, boys will have exponent 4. You get 6 combination. The question is focusing on this. So this becomes the exponent. I have to cross check if I'm on the right path. Exponent of the first one. I say they use the other way around. They use the shorter method.
Okay.
But if you're using the longer method, this is what we are talking about, right? Plus
Okay.
you want j exponent what? 3 plus j exponent 4. But that one is too long. Right? Too long. So let's use the shorter approach. So the shorter approach is going to be what? From here. 1 minus having j exponent 0. Whenever j is having exponent 0, b will be exponent what? 6. So that I get this
6.
combination. Then the 0 will come here. 0. Right? Let me check something here. They use 6 combination, 6 over here. It works in a way, but sometimes I just have to be careful.
Okay.
There's a classic question in the Nigeria 2025 or 2024 WASI where this method was very much employed because this combination 0 is 1 and also this combination 6 also 1. So it will trick you. Now this one, solve it this way, plus if you have j exponent 1, b will be exponent 5, and 6 combination 1. Check if this, that's how they did the second one. They use they interchange the exponents. Let me check if this one is okay. And this is 5. 5 boys, 1 girl. Also use 1 girl, 5 boys. Let me check this one. This combination 1. Oh, this is half. Because I'm using the half, I'm not getting what I'm looking for. I'm just looking for distinction.
Okay.
3 over 32. So you see, no girl and 1 girl. So I no girl, 1 girl. You subtract. This one is the no girl. So they are strictly using the formula. They want over a time. The first one to carry the exponent of the distance. Right? I'll find a Nigeria question and help you out with this.
Okay, sir.
For now, you see the question is talking about boys and girls. So why should we pick the exponent of the boy at the expense of the exponent of the girl? The fact that you started with boy and girl, you focus on what? The distance. You let me do it and see if I'll get the same answer. So I do it combination 0. Now at this point, it's better use a table approach, right? So this table approach, open the bracket, right? This combination 0. By this case, we are writing this combination x, because the x can change from 0 to 1 to any number, right? Then probability of boy is half. Exponent 6 half exponent 0 exponent x. Let me do here x minus 6 minus x. So we start from 0 and we end at 1.
Okay.
Number 64 plus number 32. Minus 1 over 64 plus 3 over 32. 57 over 64. I have the same answer. 57 over 64. Well, yeah, they had 1 over 64 plus 6 over 64.
Okay.
So me, that's how I'll be doing it too. But I want a special. You are going to get that question.
Okay.
So I have to understand that it's where the focus is on. Over here, the focus is on the girls, right? So I place my opponent on the girls. We want girls which are greater than, which are less than 2. So 0 and 1. So the girls have exponent 0 here. The girls have exponent 0 here. And the girls have exponent 1 here. And I'm making the fruit of the combination pick the exponent of the girls. Or better still, what the person is talking about. And I use it exactly the same as the book is rather picking using the formula approach. Let's see. I'll try and get a question that's having 2 probability values. So right here, it seems the half is always giving similar answers. Because theorem cannot be true unless it works for all situations before you can say this technique is true. We've done
Yes.
this 3 girls. Now let's do at most 2 boys. Probability of what? At most boys. Okay, so I want you to say what you can do about this one. What do you have in mind? When you say at most 2,
At most 2 boys is going to be 2 less than b less than 2. B less than or equal to 2.
b less than or equal to 2. Very good.
Yes.
So it means we want b to be, if you are listing this thing, 0, 1, and 2, right?
Yes.
Or better say, let's list all of them and underline what we want. 0, 1, 2,
Okay.
3, 4, 5, 6. But we want only these people, right? So it means we want b to have exponent 0, b to have exponent 1, b to have exponent 2. In that case, J will have exponent 6, J will have exponent 5, J will have exponent 4. And we are focusing on b, so the combination becomes this combination 0 right here plus this combination 1 plus this combination 2, right?
Yes.
Also the focus.
Yeah.
This combination 0 half exponent 0. One more space other than intro. Another half exponent 6 plus 6 combination 1 half exponent 1. Another half exponent 1 plus 6 combination 2 half exponent 2 half exponent 4. Then the rest is calculator. Now the calculator, when you are doing something like this, the best approach is the table approach. Mode 7. You write the table. In the table, you know the pattern that is changing, right? Which one is changing?
Okay.
Which part is changing?
X.
X. Which one is the X? The X is this part. This part. Now this part, is it picking from the second one or the first one? In my approach, it's picking from the first one over here. Right?
The first one. Yes.
This the other one will be 6 plus X. So open bracket half exponent half exponent 0 x. Then we open bracket again half exponent 6 minus x. So that in the case where x is 1, it becomes 6 minus 1. We get 5. And the right one
Yes.
here should be 5. Oh, I beg you. If here is 0, here is 1, here should be 5. 2, 4.
Okay.
We start from 0. And we end at what? 2. 0, 1, 2, right? 0 and at 2. The step is 1. So we put it, you get a fraction. So this is 1 over 64. 1 over 64 plus second one gives you 3 over 32 plus the final one gives you 15 over 64. Let's add this thing and see if we get our answer correct. 1 over 64 plus 3 over 32. It's just like the previous question we saw.
Yes.
11/32. Same answer. 11/32. I'll see. I'll see. So something like you see this one, is having 0.9 and the other one is 0.1. Let's solve this one as a last example so that we can see if our theorem is holding true. Our solution. The probability of a seed germinate is the probability of germinate is 0.9. The probability of not germinate, we can say germinate prime is 0.1. So germinate plus not germinate. Which letter is after A, B, C, D, E, F, G, H, I? Or let's use N as non-germinate. I don't want to be writing
Okay.
those referencing. So now, how many times was it done? Where from this box? Now, if 6 feet are thrown, so the number of trials is 6. And they say, what's the probability that 5 or more will germinate? Or more will germinate. Is that the inequality becomes greater than or equal to 5. So germinate should have greater than or equal to 5. If you are listing this one, is
Yes.
0, 1, 2, 3, 4, 5. How many elements? 6. Then we take the one which is greater than 0, greater than or equal to 5. So is this one 5 and 6. In this one, there's no 1 minus anything. No, this one is direct 5 and 6. We say that 5 and 6 is the shortest. Right? So in a
Yes.
situation where we want J to have exponent 5, then not J will have exponent what? 1. Then this is the focus. So this becomes 6 combination 5 plus the germinate. We want the germinate to be having exponent germinate to have exponent 6. Then not germinate to have exponent 0. So that's 6 combination 6 combination to pick from here because that's where we are focusing on. Right? So let's see. 6/5. Sorry, 6 combination 5 times germinate 0.9 exponent 5 and non-germinate 0.1 exponent plus 6 combination 6 0.9 exponent 5 0.1 exponent. This is 5, so here will be 4. Are you following?
Yes, sir.
I said 4, it's 6, so 6. It's 0.1 exponent 0. So go to your calculator, go and put the table mode 7. Bracket 6 combination x 0.9 exponent x exponent x because 5 and 5 are equal. 5 1 5 1.
Okay.
0.1 exponent the total minus 6 minus 5 6 minus x. Right, we start at where are we starting from? We are starting at 5 and ending at 6.
Yes. Okay.
So this one 0.354 0.354294. 0.354294 plus 354294. Second one, 0.53441. 0.53441. Let's add them. Mode 1. 0.3. 294 plus 0.53441. 0. That's the next question. Number 2. That's the answer. Let me do it. Let me do it. What's the answer? That's the answer. Let's go and check in there. 888 Question the crumple one. 5 or more. Hey, we had the same answer. 8858. That is my theory, my approach now. Okay, let's go and see. I mean, this one, the subject is talking about germinating.
Yes.
So always you look for the exponent that the question is talking about. Well, the mentions a Nigeria question. We said the Nigeria question.
Okay.
Very good question. You will not know which one to put the exponent on because they have tails. They are talking about tails, talking about heads. Charlie. And let's look at the second one. And I'm promising you this question every time it comes in the WASI. So exactly 5 will germinate. So probability that germinates exactly 5. So we want gene to have exponent 5, then non-gene will have exponent what? 1. So that's 5 plus 1 will give you 6 combination. We are focusing on the germinate. Right. And that one is already here. That answer is already here. It's already here. We've done it already. So just copy this answer for them. So there's 6 combination 5. 0.9 exponent 5. 0.1 exponent 1. That's 0.354. Charlie. 354,294. Let's go look at the description if it's correct. Yeah, exactly 5. Exactly half would germinate. Sorry, my bad. Exactly half. And half is 3, right? 6 over 2.
Yes.
Just change this one to 3.
Okay.
Change this to 3. Yes, here's also be 3. Zero point 0.01458. 0. I do it and I copy master my brain. That's the answer.
Okay.
So you see, it's very easy.
Yes.
Now, it's easy when the teacher is teaching you. Go and practice at home. Go and do more practice.
Nowadays, it's too big.
Go and do more practice at home, okay? I'm going to look at the question and send it to you on WhatsApp.
Sure.
Tomorrow will you come?
Tomorrow I'll come. I'll come around.
You go and check your something on Tuesday.
Yeah, my sister says she'll go with me, so
Okay.
I think she'll come